All right, so last class we talked about standard deviation, what standard deviation is, kind of what it measures, things like that. So today we're gonna focus on when your data is what's called normally distributed, which again, we looked at the end of the lesson yesterday, how data can be distributed normally or it can be skewed. So everything we're gonna look at for the rest of this unit is going to fall within normal distribution, which means, remember, that it would have that symmetric bell shape. And when data is normally distributed, a lot of times we will use what's called the empirical rule to analyze kind of like different sections of your data. Okay, and so what a long time ago these old scientists and mathematicians found was the relationship between how the percentage of your data was broken up based on the relationship with the standard deviation of your data. And so what we do is we kind of like take this bell curve right here. So that would be our data that's normally distributed. And then the top of your like little bell right here, this is where the mean is. And then every time you go out one, and it looks like a little bar type thing, like a little section, you're going one standard deviation out from your mean, either above or below. And what they found was kind of how much data fell within those regions. So it's called the 68, 99, 5, 99.7, there should be a decimal there, rule, also called the empirical rule. And so what they found was that 68% of your data falls within one standard deviation of the mean. So that means 68% of your data is either one standard deviation above or one standard deviation below your mean. Then if you go out from there, if you go two standard deviations out, 95% of your data falls within that range. And if you go out one more, 99.7% of your data falls within 3 standard deviations of your mean. So then you only have 0.3% left over. Okay. And so what we need to make sure we can understand is also like how to like break that apart into these smaller percentages when we're looking at different sections of our bell curve. And so I'm gonna kind of work this out again down here so I can kind of explain as I'm going over it. Okay. All right, so there's my bell curve. Your mean always splits your data in half. And I guess I don't need to go all in there. Okay, so that's what this means, your mean in relation to like the standard deviation. And so if in here we said 68% of your data falls within one standard deviation. So when I draw in these two bars, if we know that this is one standard deviation above, one standard deviation below, 68 divided by 2 is 34%. So 34% of your data falls within that range. Okay. And so then if we go out another standard deviation, we said 95% of that is already taken up there. Hold on. And so 68% is already taken up. So that means I have 27% left to split between those two bars. So 27 divided by 2 is 13.5. So that's where those two percentages came from. Okay. And so then if we go out one more standard deviation, so 3 standard deviations above, 3 standard deviations below, 99.7% of your data is found in that. But 95% is already spoken for in there. So the difference is 4.7. So I have 4.7% left to split between those two bars. So that's where that 2.35% came in. And then since this is 99.7%, that means we have 0.3% left to get to 100. So after we go out, only 0.15% of your data is found in that range right there. Okay, and so this is called the empirical rule. Okay, all right, so this will, hopefully you'll see when it's like applied, how it's used a little bit more. Okay, so this first example says the scores for a state's peace officer standards and training are normally distributed. Okay, so that's always important to know. It has that bell curve. So it tells us that the mean is 55 and the standard deviation is 12. So again, that means that the average score is 55 points or percent, whatever it is. And then if the standard deviation is 12, that means the typical data value differs from the mean by 12 points or 12%. And it says the test scores range from 0 to 100. So when we're answering questions about this data, you always want to start by sketching out your curve and labeling the number line based on your mean and your standard deviation. So your mean, again, that's always going to be that middle value. So if the standard deviation is 12, that means I'm going to add 12 going this way and subtract 12 going this way. So 55 plus 12 is 67, then 79, and then 91. And then when I subtract 12, that would be what, 43, and then 31, and then 19. So we've got 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. Okay. All right, so this one says about what percent of the people taking the test have a score between 43 and 67. So you always want to look at how many standard deviations are those values away from the mean. So, and then you can compare it to what we have up here. So 43 and 67 are each 1 standard deviation away from the mean. So if we come back up here, that's 34 plus 34. So that means that 68% of the people taking the test scored between a 43 and a 67. Okay. This next question says, an agency in the state will only hire applications with a score of 67% or greater. About what percent of the people will be hired by the agency? So you've got a couple options here. You could actually go and label, like kind of just copy down this. Just don't forget to always include the 0.15 after your 3 standard deviations above and below. That's a pretty common mistake. But usually, like, what I like to do is break it into like bigger chunks. So I always use like that, the mean, to separate it into 50% and 50%. So if we are only looking at this and above, I know that this right here represents 50% of your data. And then I know that this section represents 34%. So 50 plus 34 is 84%. So if 84% of people scored below a 67, that leaves 16% scoring higher than that. to get to 100%. So again, instead of finding like all these little pieces, I just usually break it to one chunk and then whatever else I need. But it's totally up to you. And again, since obviously you guys are doing this at home, you'll always have access to how this data is spread out. So you're kind of lucked out. You don't necessarily have to memorize it. All right, so let's look at a couple other examples here. So this is a collection of data. The time it takes to commute to one's work is normally distributed. The mean commute time is 22 minutes. I'm going to put that right there. And then the standard deviation is 2. So I'm going to go up 2, and then down 2, and there would be my curve. And so it's separated again into those little chunks based on the empirical rule. So now I'm going to phrase some of these questions a little bit differently. So now this is, what is the range of commute times that fall within one standard deviation of the mean? Okay. So we have to understand what we're looking for there. So there's our mean. One standard deviation is one interval out. So that range would be 20 to 24 minutes. Okay, so if I asked you that about the percent, we would be able to say that 68% of people take between 20 and 24 minutes to commute to their work. So you have to make sure you know whether you're answering like a numerical answer, a percentage, things like that. So this one again goes back to the percentage. What percentage of the data values are between 18 and 20 minutes? Okay, so this little section, we need to figure out what percent of the data that represents. So this right here is between 1 and 2 standard deviations away from the mean. So that's this little section right here. So that would be 13.5%. Okay, the next one says if there are a total of 450 commutes in the data set. So we don't know exactly what the numbers are, but we know that there's a total of 450. How many commute times are between 20 and 22 minutes? So this isn't looking for the percentage. This is looking at the actual number. Oh, and I just realized I forgot to answer this question. So this says between 18 and 26 minutes. So this is a bigger range. So here I would maybe recommend actually writing down those percentages. So 13.5, 34, 34, and 13.5. And then adding them all together, or just kind of remembering, oh, 18 and 26, that's 2 standard deviations away in either direction, so that's going to be the 95%. Okay, sorry. So now back to this question. So if there are 450 commutes in the data set, how many are between 20 and 22 minutes? So if we look up here, we know that 34% are within 1 standard deviation of the mean. So we need to figure out what 34% of 450 is. Okay. So one way to set that up is just using multiplication. 34% of 450, which is 153. Or you could set it up as a proportion. So how many out of 450, and then your percentage would be 34 out of 100. When you cross multiply, you'll get the same answer. All right, and so this next question says, if a certain commute time is exactly 3 standard deviations below the mean, what is the commute time? So if you have your curve all labeled, you should be good to go. You just have to go 1, 2, 3, and that gets us down to 16 minutes. And then same with this question. If one commute time is 24 minutes, how many standard deviations is this from the mean? So 24 is here, so that is 1 above. Alright, so last example, now we're going to draw our own curve from start to finish again. So this is the time a fire department takes to arrive at the scene of an emergency are normally distributed with a mean of 6 minutes and a standard deviation of 1 minute. So you always start by drawing your curve. So if my mean is 6, standard deviation is 1. So I'm going to go 1, 2, 3 above in 1 minute. Just going to go 7, 8, 9. And then 1, 2, 3 below. So and that means that 99.7% of your data falls between 3 and 9 minutes. So it says for about what percent of emergencies does the fire department arrive at the scene in 8 minutes or fewer? So here is a case where I would probably figure out maybe what this little section is and then subtract that from 100. So you can kind of again match it right here. So our 8 is 2 standard deviations above the mean. So 1, 2. So that means right here is what I have left. So 2.35 plus 0.15 is 2.5%. So that means that 100 minus 2.5 is 97.5. So 97.5% of your data falls under 8 minutes. And then this last question says the goal of the fire department is to reach the scene of an emergency in 5 minutes or less. About what percent of the time does the fire department achieve its goal? So we're looking for this section here. So I'm going to chunk this again. So if I know that this is 50% and this is 34, that's 84%. So if 84% of your data is above 5 minutes, that means that 16% of your data is below it. So again, it truly is just kind of how you see it. Okay. All right, so for your homework tonight, it's a worksheet posted on Canvas. There are 11 problems on it. Okay. What I want you to do is pick any 5 from 1 to 10. And then everyone has to do number 11. It's another just practice finding standard deviation. And so again, you get to pick any 5 from numbers 1 to 10, but everyone has to do number 11. So you should be submitting 6 problems total. Okay? And then as always, just let me know if you guys have questions.